Hello there again, this is Mr. Dunaway. Welcome to Chapter 5, Section 8, Scale Drawings and Models. You should have this template in front of you. If not, hopefully I've put it on my website and you can get it there and download it, print it off, or do the work on another piece of paper. What I'd like to begin by doing is obviously write your name on your notes here. And let's put a topic sentence up here at the top just so that we all understand what it is we're doing. And the goal for today is to use a proportion to solve scale. That's our key word for today, scale model problems. Now, if you've kept up in class and done the use the proportion to solve the applications that we've been doing, this should go pretty simply for you after I show you one little trick, and we can make it look exactly like the work we've been doing, which I think for the most part people have picked up quite well. To begin with, let's make sure we understand what's happening in a scale model as I begin reading right here. A scale drawing or scale model is used to represent an object that is too large or small to be drawn or built at actual size. Okay, so keywords here, or key sentences, is the next one especially. The lengths and widths of an object on a scale are proportional. Let me start that over. The lengths and widths of an object on a scale, drawing, or model are proportional to the lengths and widths of the actual object. And this is basically how they make maps. Or if they have an architect builds a building at a smaller scale, this is exactly what's happening for them to make that look like the actual thing, only smaller or larger. The scale is determined by the ratio of the given length on the drawing or model. Okay, so it's the ratio of the given length on the drawing to, that's the ratio, so it's the length of the object compared to the corresponding length of the actual object. Okay, sounds more complicated than it really is. Let's say that this is an example of a scale right here. All right, 1 inch is equal to 3 feet. This is what it means. It means that 1 inch on the model represents an actual distance of 3 feet. Or the second one, here 1 centimeter is 2 millimeters. That means that 1 centimeter on the model or the drawing is equal to the actual distance of 2 millimeters. There, so the bottom one you would have an object that is actually bigger than the actual thing. Let's say you wanted to look at a blow-up picture of, I don't know, a little tiny object such as an ant, and you want to make a large ant, you might use the bottom one here, or if you want to make something smaller, you might use the top one there. So the scales are written so that the unit length on the drawing is listed first. Okay, so that's important to understand, that when whatever the drawing is, not the actual one, but the drawing or the representation is the first thing that's listed. All right, so here's our trick, okay, to make this really simple, because what I need you to be able to do is, if I give you a scale and then I give you one of the other pieces of information, you can either figure out what the actual size is or what the drawing size should be. And this is all you do right here. Here's the magic trick. All right, use the scale as a ratio in your proportion. It's really easy to do if you've kept up with the work we've been doing this week. All right, it might sound, if you don't know what all those words mean, we should, but we're going to take this scale, like 1 inch is 3 feet, and we're going to turn it into a ratio that would look like this, like 1 inch per 3 feet. All right, and then we would set that equal to something else. It would be inches over feet, because the labels have to match, as we've been working on in class there. So that's the trick. If you can do that and then fill in one of the other pieces there, you can do crisscross and divide and have the solution. Let's take a look at number 1. You'll see how easy this really is. On this particular problem at the bottom of your page, It says on a map, 5 inches represents 100 miles. Okay, so right there it is. That's our key information. 5 inches is 100 miles. That's our scale. So let's write that down. 5 inches equals 100 miles. All right, the question says, how many inches would there be between two cities that are 2,500 miles apart? So you know that there's a city. You're making a map, and there's a city that's 2,500 miles apart. You've chosen this scale, 5 inches is equal to 100 miles. So what you're trying to figure out is how many inches inches represent 2,500 miles. That's what you're trying to find out. Okay, so we're going to use our trick. We're going to say, all right, 5 inches per 100 miles. That's equal to, well, I know I want it to be equal to 2,500 miles. Now look how I'm using the labels again to tell me where everything goes. I want to know how many inches, x inches, is equal to 2,500 miles. So now you should see something. You should recognize that. That's a proportion. Now we just do our crisscross trick. 100 times x is 100x. That's equal to 5 times 2,500. That's 12,500. And there you have it. Now remember what we learned in class. We divide by that number that's being multiplied right there. And we get x is equal to 125 inches. Why do I know it's inches? All I did is I looked back up at my original problem. Inches is there, and I know that is what we're solving for. So 125 inches on this map would represent 2,500 miles. And that's really all you have to do to solve these problems. It's really pretty simple. So take a moment and go to the next question. And if you so dare, hit pause and see if you can work through the problem correctly. And come back and I will talk you through it. Okay, ready, set, hit pause now. Okay, welcome back. If you finished the problem, I'm going to reveal it to you right now. First thing I want to point out for you is you should have identified what the scale is. It's right here. That's scale. 5 centimeters is 3 feet. And here's what I'm trying to figure out. Okay, if I have 75 feet, how many centimeters would that be? So 75 feet would be how many centimeters? So the first thing we would do is set up our proportion. Again, allow me to point out that this side of the proportion, I put 5 centimeters over 3 feet because that was my scale. Always start with that and the problem becomes really easy. All right, there's my scale. 5 centimeters is 3 feet. Notice how I wrote the labels down with it. You should have done that as well. And it's equal to x centimeters. That's what I'm trying to find. How many centimeters is 75 feet? Now I just crisscross right here. So once you get this set up, if you've learned how to solve the proportion, you just work it out. And I went ahead and did that for you. Crisscross 3 times x is 3x is 375. Divided both sides by 3. And I get 125 centimeters. Merely a coincidence that was the same number as the previous problem, but that's how it worked out. So that's question number 2. Hopefully it's starting to make sense to you, but let's try one more before we wrap this video up. And we can call it a 1 video day would be great. Go ahead and hit pause and try the problem below. It's similar but slightly different. See if you can work it out and I'll come right back with the solution. If you would, hit pause now. Okay, and hopefully you're back and have worked this out. Let me point out a couple things for you right here. First thing I did was I identified what the scale was. 1 inch is equal to 20 miles. And let me just point out that oftentimes, and this would probably happen on some testing, the scale will actually be written on the map, maybe in the bottom right-hand corner or the bottom left-hand corner, kind of depending on how they have it set up. But you would just take it from wherever it is. Now they gave it to you in the problem here. 1 inch is 20 miles. So that is the ratio that I used in my proportion that I'll reveal to you below. And then the other piece of information, what's different here, is they use the drawing that they show you that from these 2 marks, that's 13 inches on the map, and they want to know, well, how far is a distance is that actually from Kansas City to St. Louis in this case? So I simply did this ratio, or I'm sorry, this proportion, 1 inch over 20 miles, which was from here. That's equal to 13 inches, which was on the map, over how many miles? X miles, right there. So this actually is easier for us because watch what happens here. When I do my cross multiplication here, 1 times x is 1x, which is exactly what we want. So all we really have to do is multiply 20 times 13, which is 260. I just saw a little mistake I did right here. That's not 1 inch. That should be 1x, which is 1 inch, but 1x is equal to 260 miles right there. So 1 inch is, so it wasn't actually completely wrong, but remember we're trying to find out what is the variable. In this case, it's x miles, which is 260. So hopefully that all makes sense to you, and bring those notes to class, and you'll be good to go.